Niko Peric, and this is my breadboard and code submission for Lab 6. So for Lab 6, I learned about reading analog values into the microcontroller, and I'm also going to read through these 3 questions right here. So for 6A, I was to observe how LED1 changes on and off as I move my hand over a light sensor. Okay, so here you can see if I move my hand close, it will turn on and off. And you'll also see how LED1 does not flicker uncontrollably. And the reason why it doesn't flicker in that sense, LED1, is because a dead zone was programmed, so the signal has to cross through an entire range of voltage instead of only a fixed voltage. Okay, so the dead zone will then in turn prevent LED1 from flickering uncontrollably. And now for 6B, we're to modify the main loop so that the room temperature reading increases by 2% over the room value, LED2 turns on. If the temperature decreases back to the original room temperature or below it, LED2 will turn off. And in addition to this, LED2 should not flicker. So here you can see my, this is my temperature sensor. So if I hold on to it, you can see here, LED2 turned on, and that's because the temperature increased. So at a certain point here, we should see LED2 turn back off. So now for 6C, I was to modify the main infinite loop so that every time I touch the touch switch, LED3, and the green light here is LED3, it will toggle between on and off. LED3 should not flicker. So here, you see here, if I touch it on, off, on, off, on, and it's not flickering. And also going back to what I said earlier, we refer to why LED1 not flickering as alternate between on and off as the hysteresis concept as well. Okay, so now I'm going to show my code here. Alright, so here you can see I have my initialized values, function prototypes as well, and read the initial room values, light room, touch room, temp room, and so on. We have an infinite for loop as well. We have light controlling LED2 on the launch pad. We have variable dim LED. We use a light reading range, limit 50 to 900, and convert them to 0 to 100%. So here I initialize dim LED with light, which initializes to 0. And you can see here I have my modified value, 1023 minus 800, represent dim LED now. And this is also, so if dim LED is less than or equal to 10, dim LED equal to 0. Else if dim LED is greater than equal to 99, dim LED equal to 100. And that we have a function call here. Okay. Section 1.3, and this is our light controlling LED1 breadboard. So if the light, so what's going to happen here is if light is greater than or equal to light room times 1.01, my specified value here, then we have LED1 turning on if it's dark, and if light is less than or equal to light room time 1.005, then LED1 will turn itself off, as you can see by the and equal. Okay. And so here, section 2.3, we have a temperature control in LED2, and this code will cause LED2 to fluctuate as the temperature crosses the value of temp room time 1.004. So, yes. So if the temperature exceeds on the temperature sensor pass a default threshold, the LED will turn on. If not, it will default back to its original state, which is off. Okay. So here for section 3, we have our touch control in LED 3. The following code uses a dead zone and no action between 0.07 and 0.09 of the battery touch. So here you can see if touch is greater than touch room times 0.07 and touch is greater than touch room, then yeah. We also have our other statement, else if touch is greater than touch room times 0.09, we have a flag set to 0 and delay cycles run. And then this is when LED 3 would actually be off. And whenever the flag will be set to 1 or 0, that's when LED 3 would also turn on. And if you remember back in the beginning, we initialize a flag to be set to 0 by default. Okay, so that means LED 3 will be in a default state. Thank you for watching my Lab 6 breadboard submission and code review. Thanks for watching. My name is Niko Peric.